I'm on page 152. I'm looking at the Unit 1 chapter review. The first set of problems 1 through 10 say match the graph of the corresponding function, use your knowledge of the function behavior and not your grapher. So let's take a look at a few of these. Originally I was going to do the odds, but we can look at, I guess, quite a few of these. So if we take a look at 1a, and I'm just going to make a rough sketch. First of all, it's a quadratic. I know it's a parabola. That -1 lets us know the graph shifts down 1. So our graph would look like the following. So if I scan through, I'm looking for one that shifts down 1. It looks like it corresponds with number 9. So I'm just going to put this goes with number 9. Okay, graph B, again it's a quadratic, but in this case it actually shifts up 1. So I'm going to put 1B on the same graph. I go up 1, it looks like the following. Again, scanning through those, it looks like it corresponds with number 5. While we're here, let's just see if there's any other quadratic equations. There are. If you look at C and D, I'm going to go ahead and put them on a separate graph though. So C and D are translations left and right. So if you look at C, it's going to go right 2. And again, it's a parabola. So let's scan through those. That looks like it corresponds with number 8. We take a look at letter D. It's going left 2. Again, scanning through our options, corresponds with number 1. E, x minus 1 over 2, that's a linear function. I could even break it up into y equals mx plus b. This would be y equals 1/2 x minus 1/2. If you scan through all of your options, your only option for a linear function is number 10. Next one, letter F, and if you look ahead at G, both of these are absolute values, so again, I'm going to put them on the same graph. If you look at F, it says x minus 2, so that means I'm going right 2. Again, absolute value, I know it's a V, so that was letter F. Looking through those absolute value, looks like it corresponds with number 2. G, again, absolute value, but it says plus 2, shifts to the left 2. Again, scanning through our options there, G corresponds with number 7. Letter H is y equals negative sign of x. So the sign graph is a wave. What's unique about that, if there's no translation, it is centered at the origin. So it looks like the following. If you notice, though, it has a negative out in front. So just to emphasize the fireproof form, I'm going to write this as y over -1 equals the sine of x. So notice I have a reflection over the x-axis. So here's that x-axis. That means everything reflects over the x-axis. So instead of going up, the graph actually goes down first and then up. So if I scan through there, it looks like it corresponds with number 4. Letter I is y equals e to the x minus 1. That's an exponential growth, so if you scan through those, and again, though we've got a translation of down 1, it should look like the following. That corresponds with letter I. And finally, that cosine, if you look at your options that are left, it ends up corresponding, so J corresponds with number 6. The cosine graph, similar to the sine, but it starts at the point 0, 1. It looks like the following, but if you look at your equation, it said cosine x plus 1, so everything has shifted up 1. Main idea is you want to know those parent functions, be able to identify, mainly we emphasize domain and range, maybe some increasing, decreasing, etc. Okay, moving on to question number 11. I have y equals x cubed. I know that's a cubic. Looks like the following. They're asking me to list domain and range. The domain is -∞ to infinity. my range is the same thing. I know it doesn't ask for it, but just trying to help you out, I'm looking for odd versus even. Actually, that comes later, so we will wait. Moving on to 13. And I'm going to pause, and actually I think I know what this one looks like. This one, if I went and wrote this, and I know most of you are going to plug it in your calculator, that's fine. If I did factor it, it factors down to x plus 1 times x plus 1, which is x plus 1 squared. So I know it's a quadratic in a parabola. The plus 1 lets us know it shifts to the left one, and I'm looking at the following. So our domain again is negative infinity to infinity. Our range, we're starting here and we're going up. So that would be a 0, infinity. 15, absolute value, I know it's a V shape. If I wrote it in that fireproof form, it would be y minus 8 over 3 equals absolute value of x. I know most of you are going to graph it in a graphing calculator, but again, trying to emphasize some of the other topics we talked about. So, it's an absolute value. There's no shift left and right. There is a shift up 8. So, I'm just going to estimate where that would be. And I am stretching it vertically by 3. So, that means it's going to be a little skinnier. Domain, negative infinity to infinity. My range here, I'm starting here and going up. That point there was an 8, so we have 8 to infinity. Okay, 17, I don't know what this one looks like, so I'm going to pause and plug it in my graphing calculator. Okay, I graphed it in my graphing calculator, not a great visual. I can see it as it has an asymptote right here. So let's take a look at, 17. We have y equals x over, and we have x and x minus 2. So first thing we notice is our domain is x can't be 0, and it can't be 2. So we're going from negative infinity to 0. We are going from 0 to 2. We are going from 2 to infinity. We take a look at our range, going back at the graph, it looks like it can be everything except for that horizontal asymptote of 0. So we have negative infinity to 0 and 0 to positive infinity. Okay, moving on. Question number 19. They want us to state whether it is continuous if x is equal to 0. So let's take a look at number 19. I'll type this into my calculator. Okay, I went and graphed 19 on Desmos. Let me show you what it looks like. It wants to know, is it continuous if x is 0? So if I go look at x is 0 along here, I end up with a corresponding y value that looks like about negative 1.5. And notice there's no holes or anything like that. So our answer for that one would be yes. So 19 is yes, it is continuous. Okay, moving on to 21, they want us to find vertical and horizontal asymptotes of the graph. Be sure to state your answers as equations of lines. So 21, our vertical asymptotes come about from the denominator. So as I write this down, I'm going to factor the denominator. We have x and we have x minus 5. So the vertical asymptotes are x is 0 and x is equal to 5. Our horizontal asymptote, we can sketch it. Some of you also eventually kind of noticed a pattern. I'm going to go ahead and use that method for sketching. So we've got the equation. Let's see if I can get a little bit better light. There we go. We have 5 divided by, in parentheses, x squared minus 5x. Close that. Let's hit the graph. So if you notice, you've got three parts here, here, and here. Now, notice this one is coming closer and closer to 0. The same thing is true over there, so we do have a horizontal asymptote of y is equal to 0. Okay, moving on to question number 23. They want us to find asymptotes for the second one. So notice you have a radical and it's under the denominator. So again, what I would first be thinking for my vertical, I need x squared plus 10 to be greater than 0. Notice when you go and solve this, you end up with imaginary numbers, which we don't deal with. So that means x can be anything I want. When I square any value and I add 10 and I can take the square root, I end up with numbers. So there are no vertical asymptotes. Let's go take a look at the graph for the horizontal. Okay, on 23 for my graph, I can see there's no vertical asymptotes. It does look like there's some possible horizontal. Notice it tapers off here and here. Kind of tough to see. I'm going to go into that table and let's go see what happens as our x's get larger and larger. Notice they're getting larger, but they're definitely tapering off. It looks as though it's possibly a 7. I believe it's a -7 in the other direction. Another way I could check it, if I wanted, I could go into that table and I could ask it. So let's see. If I go and type in an x of 100 or an x of 1000, notice it's coming close to that 7. And again, if I wanted to go in the other direction, -100, it's coming close to that -7. So we have two horizontal asymptotes. Y is 7, y is -7. Moving on to question 25, they want us to state when the intervals when it is increasing. So 25 I actually know. Again, if I looked at it in that fireproof form, I see this as a 6y equals x cubed. If I wrote this, this would actually be y over 1/6 equals x cubed. So I have a cubic equation with a vertical shrink of 1/6. So my snake, that just means it's going to get even shrink. And they want to know when is it increasing. So remember, I'm looking at it from left to right. In this case, it's increasing all the time. So that would be -infinity to infinity. Let's go take a look at 27. I don't know the graph of that. I'm going to pause it for just a minute. When I look at this graph, it actually looks like it's increasing as well, other than those asymptotes. So it looks like it's increasing from -infinity to -1, -1 to 1, and from 1 to infinity. And this one's pretty similar to what you saw on your quiz number 1. So again, -infinity to -1, -1 to 1, and 1 to infinity. Alright, question 29, they want us to tell whether it's bounded above, below, or not bounded. So I'm going to go type in that equation there because I don't know what that one looks like off the top of my head. Sine of x, I need to clear everything else out. So bounded above means it has a ceiling to it. Bounded below means it has a floor and not bounded. This one is not bounded. I'm looking at number 30. Let's go try that one. So y equals, that E button should be near the natural log. It is to the x power. And now this one, if you notice, it does have a ceiling to it. It looks like it's right there, which makes sense because in this case, it has been shifted up 5. So on 31,